For the longest time, artificial intelligence was pretty much just stuff you'd see in the movies, right? But in just the last few years, we've crossed this incredible threshold. We've gone from computers that just calculate to computers that can actually create. So, how do they do it? All right, let's dive in and really open up that black box.
Okay, so the first and most important thing we have to get straight is this. We talk about AI like it's a thinking, feeling being, but that's really not what's going on. Underneath all the mind-blowing creativity and problem-solving, it's a system built on math. Not consciousness, just really, really complex math.
So we're really making a big shift in our thinking here. We need to move away from that Hollywood image of a sentient robot and get to the reality of what it is, an incredibly powerful tool that's grounded in data and statistics. So yeah, think less HAL 9000 and more like the most advanced statistical model ever built.
And that, of course, brings us to the central question we're tackling in this explainer. I mean, if it's just math, if it has zero real understanding of the world, how on earth can it generate things that feel so human, so creative? That's exactly what we're about to break down.
To really get this, the first layer of understanding modern AI is to stop thinking of it as an answer machine. You've got to start seeing it for what it truly is, a prediction engine.
And that's it. That is its entire job. Whether it's making an image or writing an email or even composing a song, it's just constantly, relentlessly asking and answering that one simple question over and over and over. It's not pulling a fact from a database, it's making a highly educated statistical guess.
Now, this right here is the perfect analogy. Just think about the autocorrect on your phone. It's always trying to predict the next word you're going to type, right? Well, a large language model, an LLM, does the exact same thing, but just on an absolutely astronomical scale. It's not just predicting the next word, it's predicting the next piece of a word, a token, based on, pretty much the entire internet. It really truly is autocorrect on steroids. Okay, so if it's just a prediction engine, how does it get so incredibly good at predicting things? How does it actually learn? Well, this is where we get into the structure that powers the whole thing.
It uses something called a neural network. And I have to stress this is only loosely inspired by our own brains, but the basic idea is kind of similar. A huge, vast web of interconnected digital neurons that can be tweaked and adjusted to recognize patterns.
So the training process is absolutely crucial. It works like this. First, you feed it a ton of data. Let's say a picture of a cat. Now at the beginning, the network is totally useless. It makes a wild guess, like toaster. Then we correct it. We tell it, nope, wrong. That feedback causes the network to slightly adjust millions of tiny little internal dials, which are called parameters. And then you just do that again and again, billions and billions of times until patterns start to emerge.
And when I say there are a lot of dials, I am not kidding. Today's most advanced models have trillions of these adjustable parameters. It's this mind-boggling scale that lets them capture all the subtle, complex, statistical relationships between ideas and words and images. And this right here is a brilliant illustration of the result. The AI learns about concepts as mathematical relationships. It figures out that the math for king minus the math for man plus the math for woman lands it right next to the math for queen. It has no idea what royalty or gender are, but it understands the statistical connection between the words based on how they're used across all the data it's seen. Now here's the thing. These basic ideas, neural networks, statistical learning, they've actually been around for decades. So why the sudden explosion right now? What was the spark that lit this whole fire? Well, it all comes down to a single, game-changing research paper that was published back in 2017.
Before 2017, AI models had a huge problem. They read text sequentially, one word after another. The issue was, by the time they got to the end of a long paragraph, they'd pretty much forgotten the context from the beginning. Then, in 2017, a paper from Google researchers introduced something called the transformer, and it changed absolutely everything.
The secret sauce was a mechanism called self-attention. Instead of reading word by word, this new method allows the model to look at a whole chunk of text all at once. It can see every single word and calculate how important each word is to every other word in the passage. This is how it finally, truly understood context. Just look at this example. A transformer-based model can instantly figure out that the word it has a very high connection score with the word animal and a really low score with street. It mathematically figures out that it refers to the animal, not the street.
This one ability, understanding context over long stretches of text, is what unlocked the incredible power we're seeing today.
So that pretty much brings us up to speed on how these things work. But where's all this technology headed? What's the next major evolution? Well, we're moving beyond simple chatbots and into the era of AI agents.
And the difference here is it's fundamental. The old AI was a passive tool, kind of like a calculator or a search engine. You give it a prompt, it gives you back a response. This new wave of AI is being designed as an active collaborator. You give it a high-level goal, and it can actually figure out the steps to get there.
So instead of just getting a list of vacation ideas, an agentic AI could actually do the tasks for you. It could go to Expedia, check the flights, book the best one based on what you like, add it to your Google Calendar, and even draft an out-of-office email to your boss. We're shifting from something you talk to something that does things for you. It's like going from a tool to an intern.
So let's pull it all together. AI isn't magic. It's a prediction engine running on a neural network, and it's been supercharged by this transformer architecture. At its heart, it's a system trained on the collective output of all of humanity. Our books, our art, our conversations, our code. Which really leaves us with one final and pretty crucial question. If this technology is just a mathematical mirror reflecting our own data back at us, what does that reflection truly show?